All right, we're on segment number 5 now. I hope I didn't lose too many of you here. Not all of this stuff is absolutely mandatory that you understand all of it. I'm hoping you can understand at least some of it, but it's really the last part here that I hope you can understand and actually do a little problem for. So just hang loose and ask me questions, post on the discussion board, and I'll try to clarify as much as I possibly can here. This is pretty complicated stuff, so if you're understanding this, you're in good shape. We're on Chapter 8, and what I want to do here is in the new book, version 9, we're on page 236. On the older book, about the same, 233 it looks like it starts with. What we're going to learn for this last thing is something called hypothesis testing. The definition of hypothesis testing is kind of a formalized way of testing whether or not a result is significant or not. It's a formalized way of testing whether a result is significant or not. You have to do like 4 or 5 steps here. This was really popular before the advent of statistical programs for doing computations. We don't use this quite as much anymore, but you got to learn this as kind of a foundational base of what this approach is. So I'm going to take you through it, and then you're going to see how it works with the problem, and then I'm going to give you one homework problem and hope that you can accomplish this. So there are a couple of steps. Step number 1 is state the hypothesis. Well, the hypothesis, let's think about that with the blueberries. We've got 2 hypotheses. One is called the null hypothesis, HO. The null hypothesis says that the blueberries didn't do anything. So HO said mu for this new group equals 80. So when people get the supplement mu, that it equals 80. Notice that we always use the population values, mu, because we really care about the population. We're going to have a sample that we're getting here, but we really care about the population in general. So the null hypothesis says that the supplement, the blueberries, didn't do anything. Of course, it's called the null hypothesis because what we ultimately want to do is when we collect our data, we want to reject the null hypothesis. The alternative hypothesis says that the blueberries did have an impact, that there was some sort of impact, so we would say mu does not equal 80. So step 1 is the null is mu equals 80. Step 1b is the alternative H1, mu does not equal 80. Hopefully that's an easy enough part of the process. So that's the first thing you do with hypothesis testing. You state the null and you state the alternative. Step number 2. Let me preface step number 2. Step number 2 is going to seem weird and bizarre at first, but there's always one way we do step 2, and it never really changes. So hopefully you can just go with that idea. What we have to do is we have to set some sort of criteria for deciding if something is significant or not. We have to set some sort of criteria for making a decision. And before we get into the details of this, I just want to go back to that thing we talked about during our first face-to-face class. Remember the idea of the psychic? Remember the idea that would you call somebody a psychic if they got 13 suits right out of 52? You would probably say no, that could happen and it's probably due to chance. But if somebody got 50 out of 52 suits, we made the statement that if somebody got 50 out of 52 suits correct, could that happen due to chance? Well, maybe, but we said the likelihood was so low that it probably isn't due to chance. That's the same kind of logic that we actually have here. So in your textbook, for version 8, I would ask you to go to, it looks like 235 and 6. For version 9, 238 and 9. What we basically decide to do is we decide that if we get a z-score that's really extreme, if we get a z-score that's really extreme, that result cannot be due to chance. If we get a z-score that's really, really extreme, then we basically decide that can't be due to chance. So for example, we said the mean here was 80. Let's say that all these people ate these blueberries and that their score after they ate the blueberries was 120. And we got the z-score at the end, and the z-score was like a z-score of 7. A z-score of 7, can that happen due to chance very often? No, less than 1% of the time. And so if we get a z-score that's really, really high, we'll basically say, you know what, that could have happened due to chance, but the probability is so low that we're going to say it's due to the blueberries. So we set a criteria. And the idea is, if you look on page 238 or 236, the criteria basically says that if we get a value in the really upper or lower regions, the upper or lower 5%, so we put an alpha, it's called alpha of 0.05, and it's two-tailed, meaning 2.5% on the one side and 2.5% on the other side, that we basically will say if we get a score in what's called that rejection region, that we will say that our hypothesis, we can reject our null and say the blueberries worked. The score that separates out that latter half of the distribution, if you go to that table and back and you find out what is the score that is that last 5%, the z-score, it's called a critical z-score, is plus or minus 1.96. In this case, the important one is the positive 1.96. So we're going to set, at almost all studies, that's what they do, they set the alpha at the same 0.05, two-tailed, and that basically tells you that the critical z-score is 1.96. That means that if you get a z-score, when you collect your data higher than 196, that you will be able to say you have a significant result. I hope I made that somewhat reasonable. If not, try to ask some questions on it. Okay, so let's keep going with this. So that's step 2. Step 3. Step 3 is actually the easiest step of them all. It's actually to do the computations. It's actually to collect the data and do the computations. So we have that z-score formula here. So let's see if we can go back to the data that we are given here. Get a little drink of water because I'm babbling on. And do the computation. Let's figure out first the treatment effect. So we said that when we had our particular sample here, we said pretend that the people who ate the blueberries had a score of 92. Can you figure out what the treatment effect is going to be then? Hopefully you figured out that X bar is 92 and the mean of the regular population was what? 80. So what is the treatment effect? Hopefully you figured out that the treatment effect is 12. Do we want that number to be high or low? We want that number to be high. If that number is high, that means that the blueberries really worked. The numerator, we always want to be high. Now let's go for the denominator. Remember what the denominator is called? The standard error of the mean? So let's figure this one out. The standard error of the mean, sigma, is the standard deviation. They give you in the problem that sigma equals 20. And do they also give you the sample size? Yes, they tell you that n equals 25. So can you figure out what the SEM is? It should be 20 divided by the square root of 25, or 20 over 5. So the denominator is 4. So the standard error of the mean is 4. The treatment effect is 12. So what's your z? We call it z obtained score. It's 3. Your z obtained score is 3. What was your critical score? 1.96. What does this say about what you found? Would this be statistically significant? Hopefully you would answer yes for this. This is statistically significant. And then you would make the real world conclusions that the blueberries really do help. Okay? That the blueberries really do help. So I'm hoping you can understand this basic idea. What I'd like you to do for an extra little problem here is I'd like you to do this other problem that I have down for homework, which says pretend that with the blueberry situation now X bar is 84 and N is 16, and then see if you can do the computations and get an obtained z-score, do the null and alternative, collect the data, get the critical region, which is 1.96 again, and make your statistical and real-world conclusions, and then tell me why these results are not significant. So hopefully that makes sense. Thank you all very much, and that will do it.